SPECIFIC POLYMERS is a French SME with a strong expertise in the chemistry of monomers, polymers, materials and coatings. We are able to custom design innovative polymers and materials that fulfill the specification of our partners and customers. Our threefold skilled in synthesis chemistry, resin formulation and physicochemical characterization allow us to conceive the material from the conception of targeting building blocks to the resin formulations. Materials and environment is one of the main centers of interest within the company. In this field, we are targeting to develop new bio-based building blocks for different kinds of resins, epoxy resins, polyurethane resins, non-isocyanate polyurethane, vinyl ester or polyester resins. Ecoxy project is fully in line with our objective in the field of material for environment. Indeed, in this project, we are developing bio-based counterparts to current petrol-based epoxy resins that are used in some specific applications. To do so, we want to develop a toolbox of bio-based epoxy resins that can bring soft to tough thermomechanical properties.
As more than 80% of the epoxy resin available on the market, the reference epoxy resins to be substituted in Ecoxy was mainly constituted by DGEBA, which is directly prepared from Bisphenol-A. To substitute this performing but highly controversial substance, we have thus to target aromatic structures. At SPECIFIC POLYMERS, we have been working for many years in developing epoxy prepared from vanillin derivatives and phloroglucinol, but also resin modifier based on bio-based and non-edible vegetable oils. Upscaling can be complex, it brings a lot of challenges to resolve before going further. In order to scale up any process, we have to strengthen all the experimental conditions we settle at lab scale and be sure that potential risks have been put aside. For instance, one key optimization is to master the exothermicity of the reaction to prevent safety issues. An increase of 5 degrees of the reaction media at lab scale corresponds to an increase of 20 degrees at industrial scale. It is more than important to find appropriate process routes to prevent thermal runaway and to make the overall process more robust. Thus we start at 5-10 gram scale. At this scale we first establish the best condition and investigate if moderate deviation around the safety parameter would affect the process safety, productivity and also final product quality. If strong influence of the parameter has been observed and could lead to potential risks, then we adjust the condition or find another process route. Then in a stepwise approach, we increase the production up to kilogram using the same iterative procedure. Our last step consists in collecting in a process book all the optimized parameters and process steps that would be required to answer further upscaling. We covered from grams to kilogram and even beyond, thanks to the preparation of this process book. It allows the transfer of our processes to our tool manufacturer, who handle the production of almost 20 kg of our innovative resin.
With an Ecoxy project, we are working on the valorization of two kinds of renewable resources. On one side, we are working on the synthesis of epoxidized vegetable oils with different epoxy content. These 12 different epoxidized vegetable oils allow us to prepare materials exhibiting glass transition temperature in between -20 degrees and 90 degrees. On the other side, we work on aromatic bio-based epoxy resins, either from vanillin or from phloroglucinol. Vanillin can be extracted from lignin, where phloroglucinol can be synthesized by bioenzymatic processes from algae. Using this kind of materials, we were able to design material exhibiting a glass transition temperature in between 90 degrees and 180 degrees. Based on the specification from the implementation process and the end users, we finally selected the bio-based epoxy resin made from vanillin and phloroglucinol as the most relevant one for the application. We scale up the synthesis of both resin and 20 kg scale in order to be able to implement automatic part demonstrators by wet compression molding. The composite part obtained from these epoxy resins and PLA fibers or flat fibers exhibited similar thermomechanical properties than the one prepared from the petrol-based epoxy resin. Finally, thanks to Ecoxy project, we were able to prepare a toolbox of bio-based epoxy resins that can be addressed to different applications. More, working on the aromatic bio-based epoxy resin, we figured out that it was possible to scale up their synthesis and make them a relevant alternative to currently used DGEBA, the most used epoxy resin prepared out of Bisphenol-A.